Hi there, in this video clip I want to look at the calculations of the concentrations of solutions. What is a solution? If you quickly look up here, there is a beaker containing water, say, and I'm going to add some common or garden table salt. The salt dissolves in the water to form a solution. So the components of a solution are as follows. The substance that's being dissolved is the solute, which dissolves in a solvent, the water. So the solute plus the solvent is equal to a solution. Simply then, the concentration is the amount of solute dissolved in a given volume of solvent. The equation, straightforward, is the concentration is the mass of solute divided by the volume, and that is measured in terms of grams, the mass of solute in grams, and the volume is measured in decimeter cubed. So let's look at a simple example. But before I do that, I have to explain about units. Often in the laboratory, if you're measuring things, they're measured in beakers or conical flasks, and they got these graduation marks. There's the level of the liquid, there's the liquid, you get graduation marks. And in the case of a burette, there's the tap, you have graduation marks there. And in the case of a pipette, I can't even draw one like that. And there's a graduation mark there. Those graduation marks are generally in centimetres. And as it's a volume, they're in cm cubed. So the first thing you have to do is, in these calculations, is to convert the measurements in cm cubed into dm cubed. And how do you do that? You simply divide by 1000. So if I said, for example, I've got 250 cm cubed, convert it into decimeter cubed, I take the 250 and I would divide by 1000. Let me get rid of that, and that is equal to a quarter in this example, if I was doing it that way. So this is what I've said, 1 centimetre cubed is equal to 1/1000th of a decimeter cubed. Okay, let's look at an actual example. Suppose I say I've got 100 cm cubed, 100 centimetre cubed of hydrochloric acid, HCl, that contains 0.5 grams of HCl. What I want to do is calculate the concentration of the hydrochloric acid. Concentration is the mass, which is 0.5 divided by the volume in dm cubed. And if we come up here, I've got 100 cm cubed divided by 1000 to convert from centimetre cubed to dm cubed, and that, let's just get rid of those noughts, 1 nought, 1 nought, that would be divided by 1/10, which is 1/10. So therefore its concentration is 5 grams per decimeter cubed. Let's look at a second example. Suppose I say I've got a solution of 10 grams per decimeter cubed of sodium hydroxide, NaOH. That is how much sodium hydroxide would be in 1 decimeter cubed. Suppose I said how much sodium hydroxide is contained in 5 decimeter cubed. It's simply 5 times as much, which is 50 grams. Quite straightforward. The only complication so far has been changing from cm cubed into dm cubed. You divide by 1000. Now, let's look at a further example. I've got 250 mils cm and whose concentration is 8 grams per dm cubed. Now, in 250 cm cubed, I've got 8 grams. So what would its concentration be if I actually had 1000 dm cubed? It would simply be 4 times that, which would be 32 grams per decimeter cubed. This is its concentration, and this is the amount of sodium hydroxide there would be in a decimeter cubed, i.e. how much solute there would be.